Hello everyone, and a very warm welcome to this University of Liverpool presentation on detecting fake chatbot accounts from Twitter data streams. This project has been successfully completed by our team Desert Storm, a name which I hope will be popular with our American and data science audience. Now let me give you an introduction and welcome you to the world of Twitter. I'm expecting we are all familiar with Twitter, the American microblogging website and social media platform where you can put out messages in the form of tweets. But with the evolution of artificial intelligence, Twitter has been facing a major problem in the form of Twitter bots. Now, what is a Twitter bot? It is an automated software that controls a Twitter account via Twitter API and uses it for tweeting, retweeting, liking, and following other accounts. Now, the anomaly in all this is that these bots behave like real users and are very hard to distinguish with. And that makes users vulnerable to phishing and scams. And to find a plausible solution to all this, in our project, we have used machine learning algorithms, mainly bag of words, random forest, and decision tree, all very popular algorithms in the field of data and text mining. Now for the data analytics part, we have implemented stream analytics using a storm cluster. And we will visualize all this data using mapping. Now the abstract of the problem finds three parts. First is the objective, which is to classify whether an account is human or bot using various features. Second is the context. Now imagine 9% to 15% of Twitter's active monthly users are bots, which can make up to almost 50 million accounts. Now that is a worrying factor for all of us. Third is the problem statement. That is to assist human users in identifying who they are interacting with. And we will be focusing both on tweet level classification as well as account level classification. That will help us from stopping the internet from becoming a place of misinformation and fake news spread through these automated streams. Now to give you an overview of the process and the steps involved, each of which we will discuss further in our presentation. First is the identifying features, where we will use various features like followers to friends ratio, URL ratio, frequency of tweets put out, etc. for identification. Second is the classification, where we'll use machine learning algorithms for decision making and classifying whether an account is a human or bot. And third is the visualization or the analysis, where we will visualize the ratio between humans and bots and display our final analysis. Now we'll ask my colleague Jin Feng to continue further and give you an overview of the aims and objectives we had before starting the project.
Hi everyone, my name is Jingfeng Pang, and today I will introduce the aims and design for our group project. And for the aims, we list 3 points. The first one is develop a system that identifies whether a Twitter account is bot or human. The second one is build a model to train the dataset using machine learning. And the third one is examine the real-time data from Twitter to detect the bot using the trained models. So, for this project, we decided to build our project into a mini batch approach. It means that we will do half part of analysis processing in real time and another part as batch model for machine learning analysis. So, the main driver class of the Storm system is Topology Group2 class. In this class, we design a Storm topologies, which consists of 1 support class and 2 bot class, and then we also decide to design a helper class which consists of several functions that we will be handling in the processing times. So this diagram shows our Storm class diagrams. In the main class, we put our consumer case and access token case for the Twitter API authentications. We also set the keywords area that we can use for searching some specific tweets related to those keywords. And in the support class, we define the source of our tweet. And we will post the tweet by using the parameters passed from the topology class. And we will pass the tweet into the bot class for the next processing. In the bot class, here mentioned we decide to use 2 bots. The first one is pre-processing bot in order to pre-processing some useful dataset information, and another is output bot class. The output bot class will collect the tuples from the previous bots and map the tuples from the previous bots into the key value pairs. And the last one is helper class. In the helper class, it will do the pattern puzzles, write to file, and read from file 3 works. So here it shows our storm topologies. We set one spot class and two bot class. One is preprocessing and another one is output, and we also set the clusters in the end. And after do that, some of the analysis is done using apart storm topologies, but to make the detection accurate and robust, we will use machine learning algorithms on our extracted dataset. So we decide to using clustering and classification algorithms like the decision trees, bag of first, and random forest for the data analysis. And we also set some rulers to detect a bot on human. For example, in the about detections, the ratio of the friends and followers of the account should be the 100 to 1, and the bot is writing the description and so on, some features. And it is the same as in the human detections. The followers should be larger and equal 30s, and we should use hashtags in the human. So after do this, in the end, we finish the whole systems. When we get the Twitter API and design all the apart storm topologies and do the first time pre-processing analysis, and we get the real-time dataset. And then we're using the machine learning algorithms to clustering and classify the analysis second time. And when we load the model that we set the rulers to detect the spam boards, and at this time we can judge the bot or human. And in the end, we will also do the analysis again to judge the bot or spam bot. Thank you.
Hello everyone, in this section we will discuss and highlight our implementation. We design our storm with 4 main components. There is the topology.java or main class to build the topology, which consists of spots and bolts. There is also spot.java, which creates the spots as the source of the tweets. And in the preprocessing bolt.java, we perform the preprocessing and instantiate the machine learning library class to classify the bots. Last but not least, output.java, we print the bots into the local file. In the topology.java, we use the Twitter API keys for the authentication. We use the 3 objects of spouts to collect a large number of tweets, 2 preprocessing bolts for balancing the works, and 1 output bolt for aggregating the result into a single local file. In the preprocessing bolt, we break down the tweets into smaller objects. We can see that there are some attributes we can obtain from an object, such as screen name or username, the username's description, location, number of followers, profile picture, and so on. We use these attributes for several tasks, such as flagging a username if it matches specific criteria, and for the machine learning part. First, we need to locate the project's directory. Then we type maven clean and maven package. We use this command for building the project. If there is no error, you can continue to type this command. Storm jar the path to the build jar and the main class. Then you can hit enter. If you see this message, it means that you are doing fine. After finish, we open this bots.html file with any web browser installed on your system. Let's click this user. As we can see, this user tweets frequently, so we indicate this user as bot. You can check the other account as well. Yes, we think that this is a bot,
The output of our project is an Excel file. The Excel file consists of a dataset which has different attributes related to corresponding Twitter accounts. These attributes are mainly integer value, string value, boolean value, or date value. The collected tweets are only those who have used hashtag bots in their tweets. The sample dataset of 1,795 accounts consists of 1,433 bot accounts. This is the snapshot of the dataset which we extracted from Twitter. It gives us details which includes name, profile location, profile description, URL, followers, friends, status, and all the different information which we have talked about. If you look at the second column, that is screen name, the majority of highlighted names includes word bot in it. Not only this, this bot includes the name bot in their screen name or in their profile description. Moreover, we have examined our dataset using various values like profile creation date, count of followers, friends, and much more. This is the graphical representation of the analyzed data, which consists of the word bot in their screen name, profile description, status, and profile name. We can easily see that the majority of the word bot is used in the status of the user accounts, whereas around 10% accounts has bot in their username, profile description, and profile name, and hence easier to analyze. This graph shows us the number of bots present among total user data. It can be easily visible that majority or more than 70% data is bot that we examined for 2 different days, which is due to the fact that we have only looked at those tweets which consist of word bot in their posted tweet or in their profile, which is in result helped us to find a large amount of Twitter bots.